Hello students, today we are going to do the last part of the chapter, which is nominal and effective rate of interest. What is effective rate of interest? Okay, when interest is compounded quarterly, half yearly, monthly, etc., the interest calculated will be more than the nominal or annual rate of interest. For example, suppose if a sum of rupees 100 is deposited at 10% interest compounded annually, so amount is rupees 100 compounded annually, and rate of interest is 10%. So rate of interest is 10%, so amount is equal to P into 1 plus R raised to n. So principal is 100, 1 plus R, so 0.10 raised to n, so 1 compounded annually. We are saying just calculating at the end of first year how much we are earning. So when 100 rupees is deposited, so what you earn is 10 rupees at the rate 10%. Okay. So when compounding is done annually, okay, the rate of interest is 10%. The earning is also 10%. So rupees 10 is the interest, which is 10%. Okay. Now, if the interest is compounded half yearly, then in that case D is equal to 2, right? Because compounding is done twice in a year. So in that case, formula will be A is equal to P into 1 plus R raised to 1 plus R upon D raised to D into N, right? So 100 into 1 plus 0.10 upon 2 raised to 2 into n. N is 1 in this case. So at the end of first year, if interest is compounded twice, that is interest is compounded half yearly, in that case, how much is the earning? So in that case, earning would be 1.05 raised to 2, which comes to 110.25. So when compounding is done half yearly, though in this case also rate of interest is 10%, but the earning is more than 10%. So in this case, earning is rupees 10.25. That is, earning is 10.25%. So when you invest 100 rupees, at the end of a year, you are getting 10.25 rupees. That means 10.25 is the effective rate of interest. Rate of interest in this case is also 10%, but at the end of the year, you are earning 10.25%. And this is called as effective rate of interest. Okay. So effective rate is higher rate achieved due to shorter period of compounding than annually. So the formula for effective rate of interest is E is equal to 1 plus R by D, the whole raised to D minus 1. Okay. This formula is very easy to remember. This is compound interest formula only without P and N. That's it. See, what is compound interest formula? Compound interest is equal to P into 1 plus R by D, the whole raised to D into N minus 1. This is the formula for compound interest, right? So you just have to remove P and N. Okay. And this way you can remember the formula of effective rate of interest. You only need R and you only need D to find out effective rate of interest. Okay. Principal is not required, nor period is required. Okay. Now let's solve the first problem. Find the effective rate of interest in each of the following cases. Rupees 5,000 lent at 10% per annum, interest being compounded quarterly. So interest is being compounded quarterly, that means D is equal to 4. Right? So interest is being compounded quarterly. That means 4 times it is being compounded in a year. So D is equal to 4. And you need rate of interest. So R is equal to 10%. Principal is 5,000, which is not required. So principal is not required. So let's solve the first part. Okay. E is equal to 1 plus r by d, the whole raised to d, minus 1. So 1 plus r. R is 10%, so 0.10. The whole upon d. D is 4 minus 1. So 1 plus 0.025 raised to 4 minus 1. 1.025 raised to 4 minus 1. Let's calculate this. 1.025 into is equal to. So 1.1038. 1.1038 minus 1. So 0.1038. That means it is 10.38%. So effective rate of interest is 10.38%. When interest is compounded quarterly and rate of interest is 10%, effective rate of interest is 10.38%. Okay. Similarly, let's solve the second part. Second part is interest is being compounded half yearly. That means D is equal to 2. Okay, because in a year twice the compounding is done. And interest rate is 8%. So R is equal to 8%. Principal is not required. So E is equal to 1 plus R upon D, the whole raised to D, minus 1. So 1 plus 8% means 0.08. Compounded half yearly means D is equal to 2. So 1 plus 0.04 raised to 2 minus 1. 1.04 square minus 1. So let's calculate. 1.04 into is equal to, it comes to 1.0816. 1.0816 minus 1, which is 0.0816. That means 8.616%. Okay. Similarly, let's solve the third part. Okay. 4,000 lent at 12% per annum. So R is 12%, which is 0.12. Interest being compounded annually. So that means in a year only once it is being compounded. So D is equal to 1. Okay. So in this, when interest is compounded annually, effective rate of interest and rate of interest should be same. It should be 12% only, right? E is equal to 1 plus R by D, the whole raised to D, minus 1. So 1 plus 0.12 upon 1 raised to 1 minus 1. So 1.12 minus 1, which is 0.12, which is 12%. So in this case, when interest is compounded annually, in that case R is equal to, rate of interest is equal to effective rate of interest. So rate of interest is also 12%, effective rate of interest is also 12% when interest is compounded annually. Okay. Let's solve the next question. At 8% per annum, nominal rate of interest, so R is 8%. If interest is compounded half yearly, that means D is equal to 2. Find the effective rate of interest. Find the period in which the sum doubles at this rate. Okay. We will solve the first part first. We'll solve the first part first. Okay. So rate of interest is 8% and interest is compounded half yearly. So D is equal to 2. So let's find out effective rate of interest. So E is equal to 1 plus R upon D, the whole raised to D minus 1. 1 plus 0.08 raised to 2, whole raised to 2 minus 1. So 1.0.0, sorry. So 1.04 raised to 2 minus 1. I think we have already calculated this. 1.04 raised to 2. Yes. It comes to 8.16%. So 0.0816. 0.0816 it comes to like this. So 8.16%. Okay. Now find the period in which sum doubles at this rate. Okay. So you have to find n when it doubles. Okay. So let principal P is equal to 100. If P is equal to 100, then A is equal to 200. Effective rate of interest is 8.16%. R is already given as 8%. And you have to find out N, right? So, and D in this case is D is equal to 2, right? Because, yes, interest is calculated half yearly. So, if we don't know effective rate of interest, still we can find out N, right? So the formula you know is dn is equal to log A minus log P upon log 1 plus R by D. This is the formula, right? So there's one more formula. If E is given and R is not given, then in that case you can use another formula, which is N is equal to log A minus, in this problem you can use any formula, okay, you can use this formula also, okay, but in the exam there can be a situation where E is given and R is not given and you have to find period, you have to find N. So in that case there is a new formula which is log A minus log P divided by log 1 plus E. Okay, this is the new formula. Please note this formula. Okay, now using this formula, please calculate N. So N is equal to log 200 minus log 100 upon log 1 plus E. 1 plus E is 1 plus 0.0816. Okay, so N is equal to, we have calculated log 100 and log 200 many times. Okay, so log 200 is 2.3010 minus log 100 is 2 divided by log 1.0816. Okay, now let's calculate log 1.0816. Okay, So n is equal to 0.3010 divided by, so log 1.0816. So 10th row, 8th column, and mean difference of 1. Okay, so let's find out. Tenth row, 8th column, mean difference 1. Okay, because before the decimal the digit is 1, so 1 minus 1 is 0, so it is 0 point something, right? So 10th row, 8th column, 10th row, 8th column is 0334. 0334. Okay, I'll write it down. 0334. 0334, and mean difference is 1, so that is 4. In this case it is 4. Okay, so add 4. So plus 4, so it comes to 0338. Okay, so 0.0338. Okay, so let's calculate this. 0.3010 divided by 0.0338. 0.3010 divided by 0.0338, correct? So it comes to 8.90 or 91, 8.91. So 8.91 years. Okay, now if you want, you can convert 0.91 years into days also. So how do you convert? If 1 year is equal to 365 days, then 0.91 year is equal to how many days? So what do you do? 365 multiplied by 0.91 divided by 1. So 365 into 0.91. 365 into 0.91. It comes to 332.15. So 332 days. 332 days. Right? So which is 8 years and 332 days. Okay. Let's solve the next problem. Find the effective rate of interest per annum equivalent to a nominal rate of 8.25% per annum, the interest being compounded monthly. You are supposed to find out effective rate of interest and nominal rate, that means R is 8.25%, and compounded monthly, that means in a year 12 times it has been compounded, so D is equal to 12. Okay, so let's find out. E is equal to 1 plus R upon D, the whole upon D minus 1. 1 plus 0.0825 divided by 12, the whole raised to 12 minus 1. Okay, so 1 plus, when you divide, it comes to 0.006875. the whole raised to 12 minus 1. So this comes to 1.08569 minus 1, which is 0.08569, or 8.57%. Okay, let's solve the next problem. An amount of rupees 5,000 is lent at 6% per annum. Interest compounded quarterly. Find the effective rate of interest. Okay, so interest is 6%. Compounded quarterly means D is equal to 4, and find out effective rate of interest. So let's calculate. E is equal to 1 plus R by D, the whole raised to D, minus 1. 1 plus 0.06 raised to 4, the whole raised to 4, minus 1. 1 plus 0.015, the whole raised to 4, minus 1. 1.0614 minus 1, so 0.0614, or 6.14%. Okay, I am sure you should be able to solve this by yourself. I'm sure you are able to solve this by yourself. Okay, let's see the next problem. At certain rate of interest compounded monthly, a sum doubles in 3 years. Find the nominal rate of interest. That means you have to find R, and find effective rate of interest, and that means you have to find E. So a certain rate of interest compounded monthly. Compounded monthly means D is equal to 12. A sum doubles in 3 years. That means N is 3 years. N is 3. If P is 100 and A is 200. Okay. So P is 100. A is 200. R you have to find out. Compounded monthly. So D is equal to 12. Okay. And sum doubles in 3 years. So N is equal to 3. Okay. So you are supposed to find R. Nominal rate of interest means you are supposed to find out R. Okay. And effective rate of interest means you are supposed to find E. Nominal rate of interest means the normal rate of interest, which is R. Okay. If interest is compounded annually, what is the rate of interest? Okay. Now let's write the formula for R. So there is D also. So R upon D is equal to anti-log of A minus log P upon D into N minus 1. This is the formula. So R we don't know, D is 12, anti-log of log A. Log A is log 200, log P is log 100 upon D into N. So 12 into 3 minus 1. So R by 12 is equal to anti-log log 200. We have calculated it many times. 2.3010 minus log 100, which is 2, divide by 36 minus 1. So R by 12 is equal to anti-log 0.3010 divided by 36. So 0.3010 divided by 36, you will get 0.0084 minus 1. Okay, now let's find antilog of 0.0084. So r by 12 is equal to antilog of 0.0084, okay, is, when you calculate, it comes to 1.020, okay. So 0.00 row, 8th column, and mean difference of 4, okay. Because the number is 0, so after 1 you will put a, after first digit you will put a decimal point. How to see antilog table is explained in the previous lectures, in one of the previous lecture, okay. So minus 1. So r by 12 is equal to 0.020, okay. R is equal to 12 into 0.020. So R is equal to 0.24 or 24%. We have found out R. Now let's calculate effective rate of interest, which is E, which is the second part. Effective rate of interest, E is equal to 1 plus R by D, the whole raised to D, minus 1. 1 plus 0.24. R we have calculated, it is 24%. Divide by 12 raised to 12 minus 1. So 1.02 raised to 12 minus 1, which comes to 0.2684 minus 1. Sorry, not 0. 1 point. 1.2684 minus 1. I would like to check this. 1.02 into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, see, 1.26 82 it is, not 84. I'll check again. 1.02 raised to 12. So into 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it comes to 1.2682. Okay. 1.2682. Okay, minus 1. So 0.2682 or 26.82%. Okay. Yeah. That's it for the day, students. Have a great day. Thank you very much.